Okay, once the recording start, na, I will press. Okay, it started. So, welcome you all for this another lecture on ultrasonic machining. In the part one, that means in the last lecture, during last lecture, we have seen that working principle of this ultrasonic machining. Then we have discussed the block diagram of USM process, as well as uh, we have discussed about the what is ultrasonic. Okay, today we'll start with the setup or various elements of USM setup, and as well as we'll discuss the parametric analysis of this ultrasonic machining process. Okay, so setup means what the all the components which are required for the our for the entire USM process. So here I have mentioned the some standard components or the elements which are required for the USM system. Okay, and these components are mentioned by the VKZ. Okay, so the first component of the USM system is sine wave generator. That means we require uh, sine waves. Okay, in detail I'm going to talk in the next during the next slide. Then second component is the transducer. Then third component is the tool holder and tool. Okay, and the last and important, that is the abrasive slurry. Okay, so these are the mainly five components or the elements of the our USM system or the USM setups. Okay, okay, now in detail we will discuss here. Now first component is the sine wave generator. Okay, now normally this sine wave generator is convert the 60 hertz power supply. Okay, that means our power supply having the 60 hertz frequency, that is going to convert to the higher or greater than or equal to 16 kilohertz. Okay, sine wave generator normally convert the 60 hertz power supply into greater than or equal to 16 kilohertz. Okay, and normally this 60 hertz hertz power supply we are getting from our lab as well as from homes also. Okay, and that we need to convert into the frequency up to 16 kilohertz or greater than that. Okay, okay, and we have the another element, that is transducer. Well, as we know that the transducer is required for generation of mechanical vibration. Okay, now transducer will take the electrical energy, and that is going to convert into the mechanical vibration. So normally this type of transducer uses piezoelectric crystals. Okay, which can have the power up to 900 kilowatts. Okay, piezoelectric crystals. Okay, which will use the or having the power 900 only watts. Okay, and the efficiency in this particular case is very high, that is up to 95%. Okay, so this is I'm telling the physics behind the transducer. Okay, this is the extra part, as well as this piezoelectric crystals are normally commonly used for the non-destructive testing purposes, as well as for the ultrasonic cleaning purpose. Okay, you can use this piezoelectric crystal type transducer. Okay, okay, but for ultrasonic machining process, okay, here normally it is frequently used for this process. Okay, mostly transducer, the type magneto-stick to type, we are using for the machining purpose. Okay, so I will talk about this magneto-stick to type transducer. Okay, because it's have the high capacity, okay, as compared to this one piezoelectric. Okay, it's have the high capacity as compared to this piezoelectric type of transducer, and as well as this magneto-stick to type transducer have capacity up to 2.4 kilowatt, 2.4 kilowatt capacity, but their machining efficiency, okay, as you can see here, is very low. It is just 20% to 30% efficiency is there. Okay, but in case of this magneto-stick to type transducer, you always require the quick response. cooling. Okay, so here for this case or for this particular type of transducer, we need cooling. So cooling is essential. But the maximum amplitude of the vibration that you can obtain from this case of magnetosensitive type transducer is 25 micron. Okay, maximum amplitude of the vibration using this type of transducer we can obtain up to this 25 micron. Okay, so this is about the transducer. I will once again repeat. This transducer is required to convert the electrical energy into the mechanical vibration. Okay, and to amplify that electrical energy, having the, for example, you can see here 60 kilowatt power supply. If you want to go for the amplification, you can use this sine wave generator. For that purpose, we have taken this element. Okay, now let us talk about the tool holder, because we know that after transducer we have the next element is the tool holder. Okay, so normally there are two types of the tool holders. One is known as non-amplifying, and another is the amplifying tool holder. Okay, in case of the amplifying tool holder, you can get 10 times higher amplitude of efficiency, amplitude of the vibration. Okay, in case of this amplifying tool holder, we can get 10 times higher amplitude of vibration as compared to this non-amplifying tool holder. Okay, so this type of tool holder it can transmit the energy. Okay, and the amplitude of vibration can be as high as up to 1 micron. Normally the material for the this tool holder, okay, it is used commonly are monel material, then titanium, then stainless steel. So this kinds of material normally used for the this tool holder material. Okay, and it the most important property of the tool holder is that it should have good acoustic properties, because their work creating the vibration. So we should have the good that material should have the good acoustic properties, and it should register fatigue cracking. Okay, so high resistance to the fatigue cracking. That is that property also important for the tool holder material, and it should avoid the welding between the tool holder and the transducer during the working. Okay, so these properties is required for the this tool holder. Okay, then we'll talk about the tool. Okay, just we'll talk about the tool holder. Now important is the tool. Okay, tool is different and tool holder is different, because tool holder is a like connector. Okay, which is required to transmit the mechanical operation from transducer to the tool. So that connector means our tool holder. Now I'll talk about the tool. Now in that tool, for this tool, normally materials like mild steel, stainless steel, brass, these kinds of material are used for the making or manufacturing of the tool in the for this particular USM process. And the main properties of this tool material are the high ductility and high wear resistance. Okay, so this kinds of the property should be there for the tool material. Okay, and as far as surface conditions are concerned, you should have good surface finish. Okay, as far as concerned with this surface condition, it should have the good surface finish. Okay, there should not be there should not be any scratches. Okay, or I can say machining marks on the tool. Otherwise, what will happen? Otherwise, they will be reflected on the machine workpiece surface. Okay, whatever scratches or any machining marks will be there on that tool. So that same scratches of the machining marks may observe on the your finished component, or I will say the machine workpiece surface. Okay, and as well as a fatigue failure of the tool will take place because due to excessive pressure. Okay, so this is the case of the tool. Okay, so the scratches and machining marks. Okay, so normally tools are subjected to very high frequency or tool changing. Okay, so tools are the subjected to very high frequency load changing. Okay, so hence I can say fatigue failure of the tool may take place if it has scratches or machining marks. Okay, in the tool. So there should not be scratches or machining marks on the tool. Okay, if that scratches or machining marks will be there, then fatigue failure will be observed. Okay, of that tool. Okay, now tool design consideration. Okay, now regarding this tool design consideration, this is required for the overcut. Okay, and overcut should be taken into account at the time of tool design only. Okay, as in the last lecture already I mentioned about the tool cut. So that tool overcut we should take into account during the tool design time only. Okay, so that you can get a desired shape and the size of the machine workpiece. Okay, and you should minimize the fatigue problem by, if you want to minimize the fatigue problem, then we have the one solution, that is we can go for the silver brazing of the tool and the tool holder. Okay, by doing this silver brazing of the tool and the tool holder, we can minimize the fatigue failure, because fatigue failures are getting from the scratches and the machining marks. Okay, so to minimize that, we can go for the silver brazing of the tool and the tool holder. Okay, let us discuss about the abrasive. Okay, so again, this abrasive is the most important element or the component of the our setup, USM process setup. Okay, so there are various kinds of the abrasives are used in case of this USM system or process, and some of these them are the alumina, that means the L2O3, then silicon carbide SiC, then we have the boron carbide before C. So these types of these kinds of abrasives are used in case of this USM system, and abrasive hardness should be definitely greater than the workpiece hardness. Okay, abrasive hardness should be greater than the workpiece hardness. Okay, because if this condition is not there, no, that means if if abrasive hardness is less than the workpiece hardness, then fracture or the break, or I will say that this abrasive itself will fracture or break rather than removing the material from the workpiece. Okay, so here we need to take care of the hardness of the abrasive, and that should be greater than the workpiece hardness. Okay, now how to select this abrasive? So there is a criteria for the selection. While selecting these abrasives, following points should be taken care. Okay, now which are the following points? This what? Hardness, then size of the abrasive, life of the abrasive, okay, and the cost of the abrasive. Okay, what is the workpiece metal hardness? Okay, what is the workpiece metal hardness? That point also we need to consider. Okay, and because it is very important to know the hardness of the workpiece. Okay, while selecting the abrasive. Okay, it should also be taken into consideration, including desired metal remove rate and the surface finish. So these points, these desired material remove rate and the surface finish, this criteria also this point here while selecting the abrasive. Okay, because what happens, low, as we know that low concentration of the abrasive is for the deep hole drilling, so that abrasive and the liquid carrying the abrasive can penetrate inside. Okay, especially if you talk about in case of complex cavities, there okay, is recommended for what purpose? To drill the, okay, for the drilling purpose as well as the for complex cavities. For that purpose, low concentration of the sorry, low concentration of the abrasive. Okay. The question arises is that how to evaluate performance. Okay. Now, how to evaluate is evaluate material removal rate, surface finish, and accuracy. So, from these uh, uh, parameters, we evaluate the process performance of the process. Okay. That we can uh, using this during the machining of the component. Okay. Okay. And as we know that this process or this process parameters are the functions of are the function of green side, or I can say green side. Okay. So message is there of this abrasive. So that is the function of sorry, this our USM process messages are ranging from mesh green abrasive parts in for the our USM process. Okay. Now, as we know that we are preparing the abrasive slurry fusion process, and I just talk about the abrasive. So let us discuss the abrasive. Okay. Now abrasive carrying
Sir,
is the water, then benzene, and so these liquid carry medium. Okay. Specific material of the liquid. So normally water is recommended for most of cases as a abrasive carrying medium. Okay, so that it can reach to the fine details, or I will say the small cavities or the complicated shapes. Okay, easily they can water can reach up to that. If it is having high viscosity, then it may not be able to reach to the fine cavities or the fine details on the component. And as we know that water gives the best result because of low viscosity. But the problem with the water as a carrier gas is that it corrodes the workpiece. Okay, so one has to okay understood what is the role or what is the function of sine wave generator, transducer, a tool connector or tool holder, tool. What will be the properties? Or what should be the properties of the tool holder material? Okay.
Sir,
Then
sir,
abrasive, which kinds of abrasive we can use, why to how to select. Ha,
again एकदा सर
I
रिपीट
know.
करा की आवाज
पुन्हा
कट
काय
होत
शंका आहे का?
आवाज ब्रेक होता
Whether my voice is whether my voice is audible.
येस इट इज
आता येते
ऑडिबल
का?
आता ऐकू येते
हॅलो हॅलो, आता येते का?
हा येते
मग
सर
ब्रेक कधीपासून झाला?
लो कॉन्सन्ट्रेशन पासून
ऍब्रेसिव्ह म्हणलं कुठनं
लो कॉन्सन्ट्रेशन
हा कॉन्सन्ट्रेशन. मग अजून रिपीट करू का ते?
हा सर
Machining using USM process. If you want to go for the deep hole drilling as well as the fine cavities or the complex cavity, where can select the low concentration of the abrasive. Okay, and to evaluate the performance of the process of this, as we know that performance of this process we can evaluate using the material removal rate, surface finish, and accuracy. Okay, so these parameters also we need to consider. Now, these parameters are the dependent of the our average grain size. So for that purpose, normally we are selecting the grain mesh size in between 240 to 800. Okay, for the averages. Okay, and as we know that we are preparing water is used as the average carrying medium. It has a low viscosity and it can reach up to the fine cavities or the fine uh, complex shaped cavities. Okay, as well as we have the benzene, glycerol. So these kinds of also we can liquid with as slurry medium. It is abrasive particles.
सर
Okay,
अजून
but
अडकले
mostly
आवाज.
water is used because of low viscosity. But there is one more problem about the water is that water corrode the workpiece surface. Okay, so and we should take care. Okay, we need to consider that. Now, whether under have you understood what I explained? Snehal Mai, Aniket Bonsure and Ritik Bosle, understood or not? Aniket,
Yes, sir.
have you understood what I explained? Snehal Mane,
Yes, sir.
Samarth Pawan. Okay, thank you. Samarth Pawan,
Sir.
Yes, sir.
have you understood what I
Yes, sir.
explained?
Yes.
बोला बोला हा ओके ओके हा कुणाला काय शंका असेल तर विचारा.
सर व्हॉइस ब्रेक होतोय भरपूर.
हा धनश्री बोला.
सर
सोनूने बोला.
व्हॉइस इज ब्रेकिंग सर टू मच.
माय वॉइस इज ब्रेकिंग.
Yes, sir.
Whether now it is audible? Hello.
Sir, sometime it's clear, but
Okay. Okay. Frequently, my voice is breaking. Oh, okay. आवाज ब्रेक झाला लगेच मला सांगा जावा. ओके, अनम्यूट करत जावा आणि लगेच सांगा. हा आता ते समजलं का? मध्ये
हॅलो सर.
का कुठे झाले?
सर व्हॉइस ब्रेक होते.
हॅलो. One minute. I will connect with the connection. Hello.
Yes, sir. Yes, sir.
Hello.
Yes, sir.
Hello. मला का माझा आवाज येईल?
माझा आवाज येतो का आता?
माझा आवाज येतो का? हॅलो.
हा सर येते सर. 2 माईक चालू आहेत सर फक्त म्हणून निको होत.
हॅलो.
आता आवाज येतोय का? आता आवाज येतोय का?
सर तुमचं 2 माईक चालू आहेत.
वायफाय चालतो. हा मी PC वरून आणि मोबाईल जॉईन झालो होतो. आता आवाज येतोय का? हॅलो, आता आवाज येतोय का?
येस सर, येस सर.
येतोय का? बरोबर. आतापर्यंत जे शिकवलं ते समजलंय का मला? वाघमोडे,
येतोय सर, येतोय.
प्रणय,
येस सर, येस सर.
हा ओके. हा स्क्रीन विजिबल आहे? हा स्क्रीन विजिबल आहे का माझी? तुम्हाला दिसतंय का
Yes, sir.
स्क्रीन? Okay. Now let us move toward the next point. Okay. Now we'll discuss about the different input process parameters. Okay. Hello. Hello. पासवर्ड आहे?
हा, येस सर.
हॅलो, आता येतो का आवाज? लागला लय मोठा गेला नंतर बघ तात्पुरता तिकडे उठला शेतकऱ्या हे लय मोठा टाकला नंतर बघ थोड्या वेळ. हॅलो, हॅलो,
येस सर.
हॅलो,
हा येस सर.
हॅलो,
हा येस सर, येतोय.
आवाज येतोय का? हा ओके. हा ओके, आता बोल. Okay. Now let us discuss the parametric analysis of this USM process. Parametric analysis for with the help of this fishbone diagram, that is the cause effect diagram. I will discuss the what are the input parameters and how that input parameters will affect the performance characteristics. The performance characteristics of the performance parameter is what? Our material remove rate, tool wear rate, then cutting ratio, surface finish. Okay, how it will affect is by these parameters. Okay, so here I have shown the fishbone diagram. Okay, so there are various parameters, okay, which affect the performance of this USM process. Okay, now you can see in this slide. Okay, so this is fishbone diagram. It shows the various parameters which affect the USM or ultrasonic machining process. In case of first one, slurry. A slurry is the first process parameter. Okay, slurry is the process parameter. Now in that, feeding mechanism of slurry, then temperature of the slurry, concentration of the slurry, abrasive type, volume fraction of fraction, grain mesh size, viscosity of slurry, and liquid carrying medium, that abrasive carrying medium. So these all parameters will come under the slurry, and this slurry is the one parameter which affect the performance of USM process. Got it? So here we need to consider what is abrasive type that you are using, volume fraction of the abrasive in the slurry, size of the abrasive particle. Okay, so this we have to consider. Then viscosity of the slurry. Okay, this viscosity of slurry. Okay, here because viscosity means what liquid medium you are using. So that we need to take consideration. So for that purpose, viscosity is important parameter. Okay. Now next important parameter is the tool. Okay. So in that again, whether you are using single tool for ultrasonic machining or multiple tools. Okay. Multiple tool means what? More than one tool can be used for the machining at the same time. At the same time, you can use more than one tool. That time you can say multiple tools. So this parameter also we need to consider. Okay. Then tool material. Okay. So what are the damping characteristics of the material of the tool, and what is the ductility of the tool? Okay, or that tool material. Okay. So both we need to consider under this tool material. Okay. So both of these will affect the performance of this USM process. Okay. And another very important parameter is the surface finish of the tool. Okay, surface finish of the tool. As I have already mentioned before this lecture, if scratch or during this lecture, if scratches are there or the micro cracks are left on the tool surface, then it will quickly fail because of ultrasonic vibration and the load acting over it. Okay, so surface finish of the tool, that is also important parameter. Okay, if surface finish is not good, then this will be reflected to the some extent on the finish of the machine component. Also, another parameter is the definitely geometry of the tool. Okay, that also will affect the geometry of the machine cavity that you are going to get on the workpiece. So these all parameters come under this tool, and this tool is the important process parameter which will affect the performance of this USM process. Okay. Now let us discuss about the workpiece properties. Okay, you can see here workpiece properties. In that again, what is the type of the workpiece material? That also affect the selection of the process parameters. Okay, type of the workpiece material. Then important, what is the hardness of the workpiece material? That should be considered, because according to the hardness of the workpiece, you have to select the type of the abrasive particle. Okay, then what is the thickness of the workpiece, and what is the strength of the workpiece material? Okay, will also affect the performance of this ultrasonic machining process. Then another is the amplitude of the vibration. Amplitude of vibration is going to affect the performance of the process. Okay, and how much static load is acting. That will decide with what velocity of the particle is going to hit the workpiece surface. Okay, so that static load also we need to consider. Then we have the type of the transducer. In that again, which type, that means piezo type we are using transducer or magnetostrictive. So that type also affect the performance. Okay, then what is the power input? Power input to the transducer, or the force with which you are hitting the abrasive particles, which will carry with it. Okay, so this power input to the transducer. Okay, that is also important. And the last one is the frequency of the vibration. Okay, frequency of the vibration also affect the performance of the process. Okay, And finally, there is another process parameter which affects the performance of process, that is the tool holder. Okay, tool holder, and the shape of the tool holder and the material also affect to the some extent to the performance of the this USM process. Okay, so shape of the tool holder, material of the tool holder, that also affect the performance of this USM process, but up to some extent it affects. Okay, and as I have already mentioned earlier that you can evaluate performance of the process in terms of material removal rate, that is MRR, tool wear rate, okay, and cutting ratio. Cutting ratio means what? Cutting ratio means it is nothing but ratio of MRR and the tool wear rate. Okay. So this is about the process parameter, or I can say parametric analysis. Understood? If you understood this, then you will get easily, you will understand the effect of this process parameter. Okay. Understood? Hello? Can anyone say yes or no?
Yes, sir.
Okay. फिशबोन डायग्राम म्हणजे काय, कॉज इफेक्ट डायग्राम. कॉजेस म्हणजे काय हो, तर हे प्रोसेस पॅरामीटर जे क्वेरी, टूल, टूल होल्डर, मशीन, वर्सेस, हे काय तर कॉजेस आहेत. आणि यांचा इफेक्ट म्हणजे काय तर परफॉर्मन्स कॅरेक्टरिस्टिक्स, म्हणजे कुठला तुमचा मटेरियल रिमूव्ह रेट, टूल वेअर रेट, कटिंग रेशिओ, सरफेस बेस. ओके सर, आता आपल्याला समजलं की कुठलं पॅरामीटर अफेक्ट करणार आहेत आणि कुणा अफेक्ट होणार आहे ते समजलं. आता कसं इफेक्ट करते ते आपण बघू. ओके, नाउ विल मूव फॉर द नेक्स्ट वन. Shall we proceed? Say yes or no?
Yes, sir.
जयदेव, अमोल माळे, जयदेव, मदन पाटील, पुढे जायचं का?
Yes, sir.
Yes, sir.
Okay. Okay. Now we'll discuss the effect of these process parameters on the performance. Performance means what? Your material removal rate, surface finish, okay, then tool wear rate and accuracy. Now the first process parameter here I'm going to consider that is the amplitude of the vibration, and how this amplitude of vibration is going to affect the penetration rate. आता पेनिट्रेशन रेट म्हणजे काय तर तुमचा हे मटेरियल मस्निंग रेट. ओके, जेवढं ऍब्रेज पार्टिकल पेनिट्रेट होणार आहेत आत त्या सरफेस ऑफ द वर्कपीसवर, ओके, तेवढे तुमचं मशीनिंग होणार आहे. सो penetration rate is the output parameter and amplitude of the vibration is the input. Okay, so I will discuss this one. Now you can see see on this slide. Okay, so this slide shows the relationship between amplitude of vibration of the tool, okay, amplitude of the vibration of the tool and the penetration rate, that is penetration rate of the abrasive particle into the our workpiece. Okay, you can see here that as the amplitude of the vibration is increasing, the penetration rate is also increasing. Okay, you can see here, but beyond a certain value, this is trying to become more or less stable. You can see it. Beyond this limit, it is trying to become stable or stable, more or less stable. Okay, so the penetration rate increases up to certain limit only. If the amplitude of the vibration is increased, but beyond this value, this you can see, it tries to stabilize. And as you can see, beyond this value, that means this higher value you can consider, beyond this value, it is trying to stabilize. Okay, like this. I have shown here also arrow. Okay, So main reason of this is constant force. Okay. So since constant force, that means the force remains the same. So it tries to stabilize beyond this certain value of the amplitude. Okay. Understood? Okay. Amplitude नुसार penetration rate वाढत जाणार आहे. पण up to certain limit. After that certain point, it is going to stabilize. Okay. Then next is the, here I have shown the relationship between frequency of vibration and the penetration rate. Okay, you can see here also, as we can see as the frequency of vibration, because we know that for the vibration there is two properties, like frequency and amplitude. Just we have seen the amplitude. Now I will talk the frequency. So as frequency of vibration is increasing, you can see the penetration rate, it is also increasing, but it tries to stabilize here. Okay, tries to stabilize. So as the frequency of vibration increases, the increases up to point, it is increasing, but it is going to try to stabilize. Okay, and with per unit time on the workpiece in object per unit on workpiece, if penetration rate was maximum, it tries to stabilize. Okay, let us discuss about the next one. Here, grain size of the abrasive grit size versus penetration rate I have shown. Penetration is your machining rate, because both are to each other. Okay, so grain size or the grit size is the another important parameter which affect the penetration rate. As you can see here, so grit size is increasing. Grit size means what? Fine size of the abrasive. Okay, their size. If it is increasing, then there is a optimum value where you get the maximum penetration rate in terms of mm per second. Mm per second will get the penetration rate, and you can see here we'll get the maximum at the top. Okay, and that means the machining of the penetration rate, that is maximum, and it also in the maximum, that means this one. Okay, maxima, it start decreasing. Okay, it start decreasing. You can see also decreasing because force is constant at different grit sizes during the experiments. Okay, so further beyond this operation, rate start decreasing. Okay, now let us discuss the hardness ratio. There is a basic question. Okay, so hardness ratio means what? The ratio of workpiece hardness and the tool hardness. Okay, so this hardness ratio is also playing already have hardness of the
Hello, sir.
Hello, sir.
Hello, sir.
Hello, sir.
Hello, sir. Hi, sir. Hi.
हॅलो सर, तुम्ही म्यूट झालाय. हॅलो.
Hello, sir.
Hello, sir.
Hello, sir.
हॅलो. हा चॅट बॉक्स मध्ये सांगा मला की व्हॉइस येतोय का नाही. अरे मी 10 कंटिन्यू एक्सप्लेन करतोय तुम्हाला व्हॉइस येत नाही का.
नाही सर येत नाही.